Record cloud. So my announcement is we have hired a new research assistant here who's hopefully going to help us with the PSWS documentation and deployment and management of a number of the keeping track of grant dollars and things like that. And hopefully this person will be starting. They're supposed to start November 10th. So I'm very excited.
Okay, any other announcements? Bill, any updates?
Yeah. As many people probably are aware, I spent last week in San Antonio at the Dash 2025 conference, which is devoted to data and software for heliophysics research. And I got to spend some quality time with the guys who wrote the HAPI specification and developed some HAPI servers that are on GitHub. But with their guidance, I was able to develop a HAPI server that runs in Django, which our whole website is based on Django. So I wasn't anxious to have yet another server type running, because then you got port conflict issues and this and that. But anyway, so I came back with a HAPI server running in Django on my laptop, and I wrote a functional specification for how to add the add code so that it would serve the data that's on the website. The only thing that is going to take some work, I think, but it's not too bad. We're not going to be able to take the digital RF files or the high bandwidth GRAPE2 files and serve them as low resolution CSV in real time. So what we're probably going to do is, GRAPE2 is a special case because we have low resolution CSV files for those in addition to the high resolution stuff. So, but the high resolution, rather the digital RF stuff, I think we're probably going to come up with another data product that is a low resolution version of the spectrum that is for display use within, like when you want to do a quick look in using the HAPI interface, and then there'll be an option to pull the entire HDF5 file that is a third data type that HAPI supports, but that's for file downloads. You wouldn't want to try and work with these giant files and try and do it in real time, because we don't have the funds to build a supercomputer that can do that in real time. But we do have a solution for that. We'll keep all the data. We'll just add an additional data product for that, for those type of files. So that is moving along quite well. I was a little bit nervous as to whether I was going to come back with a working solution, but thanks to goodness, we did. Other things going on, I'm continuing back on my process of importing files from WWV. I get a batch of files from WWV. It can only handle 10,000 files at a time, so I have to do it in batches of 10,000. Then I put the GRAPE2 data aside for now, because we have to figure out the details on how to handle that. I think I know, but what I can import immediately is all the GRAPE1 legacy data and the plots. So I'm able to import the GRAPE1 legacy data and the FLDigi plots that go with those. And so we're reading those in batches of, it looks to be about 5,000 at a crack. And so after I get them copied over to here and back up, I delete them from the WWV server, because that server is, once it gets over 10,000 files in the directory, it just basically gives up on, you can't do anything, like you can't even list a directory because it runs out of memory. So, but I do have a solution. If I treat it in batches of 10,000, and then I keep track of every file name, then I can go back and delete them name by name. Wildcards don't work because it runs out of memory. So, but anyway, we're making progress on that. I just imported a batch of 5,000 this morning, and everything seemed to work fine. So you're going to see when you look at Grape One legacy data, some of the files have the FLDigi data when it was available, and the other ones have a computed and filtered spectrum that's based on the code that was developed by Nathaniel and Christina. So there will be a plot for all of those. I also have another student who has developed a solution for plotting the magnetometer files. So once that is all tested and working, we're going to go back and back annotate all the magnetometer files we have with plots. That's coming along. Let me see, is anything else? We're having some problem with some of the RX 888s, getting them to connect to the new server. I think there is some weird thing going on that involves the authorized host file on the device and the authorized key files on our end. And then there's additional security that's been put on all of that. So we're trying to tease that apart. I have a ticket open with IT, and we're going to be looking at that the next couple of days. So there's 3 of Rob Robinette's servers, I say servers, they're clients that we haven't been able to get to hook up passwordless. They could still be used with a password, but that is anathema to Rob and his followers. So we're going to see if we can get that working for them. So that is my report. Back to Net.
What do you do with your free time?
Well, today I have to look at a contractor who's coming over to do some mold remediation in my house. And at the same time, I'm supposed to take the boat out and take my wife's church group out for a ride on the lake.
Oh,
I think that's going to be a complete waste of time because it's cold and windy and overcast. And I don't think any of these senior citizens are really going to be interested because they're going to come back with pleurisy, I'm afraid, if they can't take them out on the lake today. But we'll see what happens.
Wow.
Good luck with all that, Bill. You've got a lot going on. Thanks for all your.
Well, no more than you do, Nathaniel, but
Well, we all do, right?
Yeah.
Gary, I can see you putting in a.
Yep, I figured I'd save you a little bit of typing. Good morning, all. A week ago, myself, Dave Swartz, and Ron Logan here were out at HamCon, Colorado. Ron's wife, Gayleen, also helped at the table, which is great because that way when the 3 of us got up to go see a presentation, we had a presence there, so thanks to her too. The goal of the trip was to obviously raise awareness of HamSCI, kind of in the Western US, but also to talk to people about hosting various elements of our personal space weather station. I did have Rachel's Purcell's poster about the ground magnetometer on the table, and a lot of people were interested in that. I got a lot of questions about that, so maybe Tapper will see some sales and get some more ground mags going. But anyhow, the result of the trip is I do see a couple of new signups from that part of the country, and the PSWS interested host list. So that was kind of the goal, and so at least we got a few new names to work with. That's about it. Back to Net.
Gary, I do still have some of the ground magnetometer units when we were distributing the Grape 2s that were never taken. So I still have some sitting in my office here in a box. So keep that in your back pocket.
Are those the remote unit or the pi hats, or how does that
Those are
work?
just the remote unit
Remote units, okay.
that plug into the
I-
Grape 2s.
I have a special guest here who can give an update on magnetometer activities.
Ooh,
You're on the hot seat.
Oh, oh boy. I wasn't expecting this, but
no
so
pressure,
brief-
Rachel.
So brief update. Right now, myself with Christine Zazewski and Majid, we set up Helmholtz coils in lab space here. Right now, we're playing around with the magnetometer. We have the pair board set up. What we're going to try to do is we're feeding it a signal. We're going to see basically how sensitive is the instrument. We have an oscilloscope. So my other collaborator, Christine, her background is electrical engineering. So we're basically going to probe the magnetometer and see what we can get to do. So right now we're doing a square wave with it. We're doing a square wave. Let's see, what else are we doing with it right now? And then the other probably bigger thing is we are very slowly but surely going through all the documentation. So Dave Winton has quite a bit of the documentation on GitHub. And we've been going through and saying, okay, do we understand what X is? Do we understand what RX is? We are starting on the ground on up, trying to understand all the documentation and doing a lab setup. So what we're hoping to do is we are hoping to basically create this into some sort of almost lab activity or a training exercise for students, amateurs, scientists as well. Both, Christine has 30-some years of experience under her belt teaching, as well as doing labs. So that's kind of the goal of the project. We are saying, okay, we are taking this magnetometer and putting it in a lab setting and making sure that we understand everything about it.
Great.
All right, thank you.
And simultaneously,
news.
Majid has been building magnetometer casings. So we have, I think, 25. He's in the process of building out the PVC pipes and everything. So I think we do have a pipeline going of trying to get these things out there. So I know we may not see a lot of deployments yet, but between the work that Rachel's doing, the work that Majid is doing, hiring this new research assistant, we are taking active steps to keep the goal of deployment in sight.
It would be great to eventually on the HamSCI YouTube channel have a 20 minutes or 30 minutes about the ground magnetometer, what it is, how it works, and how you install one. That would really be cool to put that all together.
That's a really good idea.
I have a quick
Easy for me to
question.
say sitting over here, but anyhow.
Quick question for Rachel. You're using an AC source for the magnetometer excitation. Isn't the Earth's magnetic field a constant?
Yes.
Okay,
It-
so you're able to see the waveform then, you're just doing sensitivity analysis on that.
Yeah, right now we're just basically feeding in to see it, giving an AC signal. We also can do a DC signal. So right now we're just kind of basically sitting there and with a stick poking this one and saying, what, do you want to jump in here?
Yeah, let me jump in for a minute. So, you're right, John, to a certain extent, the Earth's magnetic field is a constant signal. But what the job of the ground magnetometer is, so when you measure the Earth's magnetic field, it's actually two components that you're measuring. One is the internal magnetic field, which is somewhat of a constant. And then the second are contributions from currents going in space, currents that go through the magnetosphere, currents that go through the ionosphere. And that's what causes all these magnetic field signatures that we look for in space physics. So no, the magnetic field that these magnetometers are expected to measure is not a constant. So we're actually looking at the variations. What we're hoping,
we were trying to recreate that variation.
right, and so what we're hoping, one of the things we're hoping to do with this lab exercise is to actually create some way of taking a signal generator and being able to simulate what a geomagnetic storm activity would look like in a magnetometer. What these different types of signatures we would see from space. How would that actually look in the magnetometer? So that's one of the goals of the exercise here.
Because I know one of the original setup parameters was the rejection of AC signals and the filtering and all that stuff. They played around with that quite a bit. So Yeah, it makes sense. Thank you.
You're welcome.
I would like to see that team excited with 60 hertz AC. That way, for somebody like me that may put it in my backyard and be too close to my underground power lines, we would recognize what that might look like, so we don't get fooled by something. So
That's a great idea, Gary.
I should mention something on that. I have a ground magnetometer, and it's happens to be installed within a few feet of the main feeder line that feeds my house underground. And I've never noticed any influence of that upon the
Yeah, I
magnetometer.
seem to remember there's a pretty strong 50 and 60 hertz rejection filter built into the programming of that thing. So that's how I was asking him. I don't know what the magnetosphere bandwidth events are at, but I suspect it's less than 20 or 30 hertz.
Yeah, typically the signatures we're looking for are in the ultra low frequency
That would
range,
make sense.
which are on the order of a few minutes to tens of minutes.
Yeah, that's sub-hertz, so that would make sense. That looks like DC.
Yeah, right. Yeah, so I guess it's DC. Depending on what time scale you're considering, it's DC. If you give it over a period of a few hours or a day or a year or more, then it's AC.
So I have a question, Rachel. Is there any frequency at which the magnetometer setup rings in resonance?
We haven't seen that yet. So we actually spent quite a bit of time just going through and understanding all of the data. We were going through the Linux system. We were it took more time than I'd like to say to actually get it set up to a power supply, get it set up to the oscilloscope, and kind of know heads from tails. So we have not seen that yet, but that's also, this is great I'm getting some ideas of some other things we can continue to test.
Yeah, being the sensor itself is silicon, I wouldn't expect an LC resonance or any kind of, but it's certainly possible, depending on what's wrapped around it. Back to net.
Thank you, Rachel.
Any other questions, comments, or concerns? Okay. Is Rob on? I don't see Rob. So does anyone else have any updates or things to discuss?
I'll bring up one thing.
Sure.
I was looking at the Whisper Demon data. I'm in North Carolina and it's in Massachusetts. So I was looking at the Whisper Rocks readout on the Whisper reports it was making, and it's still making about 1,500 an hour. But all of a sudden, a number jumped out at me on the display. It had 7 digits in it, and it was under the kilometers per watt column. There's 2 stations, one in well, I don't know, it's somewhere in 8 land and the other one's in 4 land. It's about 7. The one that was biggest was at 1,124,000 kilometers per watt. It's 700 and some miles from Massachusetts. And it still had 14 dB or better of signal above the threshold. So that ought to get us another hop, which would be over 2 million miles per milliwatt. Anyway, I just thought that was interesting. It's probably no record, but the station in both of these two stations were running 1 milliwatt. At least that's the stated output. Anyway, that's all I had.
Here's a little personal note thing. When I was in San Antonio, I called up Steve Serwin and said, when do we get together for dinner? And we were all set to do that. But then, as you know, he had all this radiation treatment for cancer some time ago. And now not only his hip, the hip has failed, but also his entire pelvis is falling apart. So he's in a wheelchair and has to, I don't know how you rebuild a pelvis, but he's got major surgeries closing in on him pretty fast. So he'll be out of circulation for a while. He's in a wheelchair. He wasn't able to make it to dinner. So might drop him a card if.
Yeah,
if you-
thanks. That's
So,
definitely need to do that.
Yeah.
Okay. Any other questions, comments, or concerns?
Steve's call, by the way, is WA5FRF.
And Steve just put in a tremendous amount of work getting a manuscript submitted to Frontiers about the HFTDOA eclipse experiment that he led and that a number of us participated in. So he's been doing this even in the midst of all of this pain.
Okay. Any other questions, comments, concerns, or discussion? All right. I think that's it for today then, everybody. 73.
Thank you, 73.
73, everybody.
73.
3.
Seven threes.
Everybody have a great day.
You too.